welcome to the class. In today's class, we'll be doing numbers and accuracy of math. Assalamu alaikum everyone, welcome to the class. I hope you guys are good. So I'll just give a brief intro of myself first and then we'll get started with today's lesson. My name is Harun Tariq and Alhamdulillah I have numerous A grades and world records in terms of most number of A grades for O levels, IGCSE and A levels. Um, After my academics, O levels and A levels, I went to Australia to study software systems from University of Melbourne, and I came back and then I started teaching uh, O levels and A levels, basically the Cambridge syllabus. So I've been teaching for around 7ish years now, Alhamdulillah. Um, so let us get started with today's lesson. In today's lesson, we'll be doing numbers and accuracy from math. So this would be our first chapter, and first we'll understand or we'll learn the concepts, and then we'll directly move on to past paper questions, and we'll be doing past paper questions of this particular chapter. So let us get started then. Okay. Now, first of all, numbers. So we have natural numbers. By natural numbers, basically these would be your whole numbers, but this would not include zero. So these would be your whole numbers apart from zero. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whole numbers basically. So you can't have, for example, 1.5. So you'll have whole numbers only. We can have negative natural numbers as well, but for our syllabus, we'll have positive natural numbers. And zero is not included in natural numbers. Then we have integers. These are your positive natural numbers, negative natural numbers, along with zero. A few examples have been given over here. So for example, -1, -2, -3, -4, -5, and so on. Zero is inclusive in integers. Then we have +1, +2, +3, and so on. So these are our natural numbers. These are basically our integers rather. The natural numbers were on the previous slide. So for integers, these would be your positive natural numbers, negative natural numbers, as well as zero. Next up, we have prime numbers. Prime numbers are those numbers uh, which have exactly two factors, one and the number itself. Now, what do we mean by factors? We'll first discuss multiples and factors over here. So multiples basically means times table. So for example, multiples of 2, let's say 2 times 1 would be 2, 2 times 2 would be 4, 2 times 3 would be 6, 8, and so on. So multiples of, let's say, 6 would be times table of 6. So 6 times 1, 6 times 2 is 12, 6 times 3 is 18, then you have 24, and so on. Now what do we mean by factors? Factors, basically, let's say we are discussing factors of 8, let's say. Now factors would basically mean, like, in which table do we have 8? Is 8 in the table of 1? Yes, it is. 1 times 8. Is 8 in the table of 2? Yes, it is. 2 times 4. So 2 would be its factor. 3, not really. 4, yes, 4 times 2. Then not 5, not 6, not 7, but 8, yes, 8 times 1. So these would be factors of 8. So for example, if we are looking for, let's say, factors of 12, let's say. You're looking for factors of 12. Now, is 12 in the table of 1? Yes, it is. 1 and the number itself would always be a factor. So 1 definitely, 2 yes, even number, all even numbers. 2 would be its factor. 3 no. In this case, yes, rather 3 times 4. So 3, 4 times 3, so 4 as well. 5 not really. 6, yes, 6 times 2. Then when you reach the half point, the next numbers apart from the number itself won't be its factor. So for example, 7, 8, 9, 10, 11, they are out. 12, yes, 12 times 1. So 1 and the number itself is definitely a factor. So this is the difference between multiples and factors. Multiples is your times table. Factors I just explained with a few examples, that in which numbers would this particular number come in its timetable. So those numbers are its factor. So 1 and the number itself would always be prime numbers. So for example, 3 has only two factors. They should have exactly two factors. This is the important term over here, exactly. So it can't have more than two factors, exactly two, and can't have one either. So for example, 3, 1 and the number itself, which is 3. 7, 1 and the number itself, 7. So let's say factors of 13, for example. So 1 definitely, and the number itself 13 as well, but 2 not an even number, 3 no, 4, 5, 6, 7, 8, 9, 10, 11, 12 no, but 13 yes. So it has exactly two factors, as you can see. So 13 would be a prime number. So when a number has exactly two factors, they are considered prime numbers. Composite are opposite to your prime numbers. They should have more than two factors. So for all even numbers apart from 2, 2 is the only even number that is a prime number. 2 is the only even number that is a prime number. All the rest of the even numbers, they are composite numbers. They are non-prime basically. So for example, 4, 6, 8, 9 because 3 is its factor as well. 15 because 5 is its factor as well. And even numbers apart from 2 would all be composite numbers because they would come in the table of 2 at least. Okay, now factors we have already discussed. So for example, factors of 8, which numbers have 8 in the table? 1, 2, 4 as well as 8. 1 and the number itself would always be um, factor of that particular number. Now multiples is just the timetable. Multiples of 5, for example, 5 times 1 is 5, 5 times 2 is 10, then 15, 3 times basically, 5 times 4 would be 20 and so on. Now HCF, the highest common factor. Now one method is to find the factors. So for example, factors of 8 are written over here, 1, 2, 4 and 8. And factors of 12 are written over here, 1, 2, 3, 4, 6, 12. And then we just look for the highest factor because this specifically states that highest common factor, right? So that means the factor which is the biggest number. So over here you can see the biggest number which is common in both. Common would be 4 because 8 is not neither in these two, 12 as well, 6 as well. They have to be present in both. So for HCF of 8 and 12 would be its highest common factor would be 4. There is another method. We can make a small table like this. This is the method that I recommend because it is comparatively easier and a standardized method. So first of all, we write the two numbers for which we are looking for the HCF, for example, 8 and 12. Now we try to find any number that has a common factor, which is a common factor for both 8 and 12. Both are even numbers, so 2 would be the obvious choice over here. Now 8 divided by this number 2 that we took. 8 divided by 2 is 4, so I write 4 over here. And for the next one, 12 divided by 2, which is 6, so I write 6 over here. Next up, both are even numbers again, so I can take 2. So 4 divided by 2 would be 2, and 6 divided by 2 would be 3, so I write 3 over here. Now as you can see, there is nothing common, no common factor for both 2 and 3. So we just leave it off here. And next, to find the HCF, this is for HCF. LCM is different. We'll do that in a bit. Now we just multiply everything that is on this side. So this would be 2 times 2. So this gives us 4, and 4 should be our HCF. And as you can see, we got the same HCF with this method as well. This diagram method is what I recommend because it generally gives us the answer straight away. Okay, now next up, rational numbers. Now this is important. The definition of a rational number is any number that can be written in the fraction form a over b, where both a and b should be integers. A and b should be integers. So a few examples are given over here. The signs don't matter. It can be negative or positive. So negative 3 over 4, 1 by 2, 5 by 3, 6 by 1, and so on. So this b should never be 0 because this would give us an answer undefined. So a few rational numbers which we'll discuss now. All integers would be rational numbers. So for example, if we have let's say 9, 9, can it be written in the fraction form a over b? Yes, it can. 9 divided by 1, everything is divided by 1, so this would be a rational number. Another example, so let's say we take negative 5. Is this a rational number? Yes, it is. It can be written in the form negative 5 by 1. So all integers would be your rational numbers. Next, the number 0 is rational as well. I specified the denominator can't be 0, but the numerator can be 0. So if we have 0, we can write 0 divided by 1. It would still be 0. So this number 0 is also a rational number. All mixed numbers. So anything in this form, let's say 3 whole, 1 over 5. How do we convert them in regular fractions? Basically, we multiply these two and then we add this to get the numerator. Denominator remains the same. So denominator would remain 5. 3 times 5 would be 15 plus 1, 16. 16 divided by 5. So you can see mixed numbers can be written in this form. I'll take another example. Let's say I have 5 whole and 2 over 6, let's say. Now what I do is I multiply these two. 6 times 5 would be 30, then plus 2. 32, that is our numerator, and the denominator remains the same, which would be 6 in this case. So all mixed numbers are rational numbers. So if we have 3 whole 1 over 5, this would be a rational number because it can be written in this form. All decimals which terminate, or those decimals which have a repeating pattern, they would also be rational numbers. So for example, if we have 0.2, can it be written in the fraction form a over b? Yes, it can. This is basically 0.2 divided by 1. If I multiply this by 5, of course, whatever I multiply in the numerator, I'll have to do the same thing to the denominator. So this would actually become 1 by 5. So you can see it can be written in the fraction form a over b, and both are integers. So any decimal that terminates, this was terminating 0.2, it terminate means it ends after a certain number of digits. So for example, if I have 0.5236, I don't even need to calculate it. Is it terminating, decimal and terminating? Yes, it is. So it must be a rational number. It must be a rational number. Terminate means ends after a certain number of digits. Another example given over here is a repeating pattern. So for example, if I have 0.3 recurring, the dot on top of 3 basically means this is 0.33333 and so on. It never ends, keeps on repeating. This can actually be written in the form 1 divided by 3. 1 divided by 3 comes out as 0.3 recurring. So this would be a rational number as well. If you have a repeating pattern, this is only for a repeating pattern. If it doesn't end, if it is non-terminating, there should be a repeating pattern. If there is, then it would be a rational number. So for example, if you have 0.702, now if I put a dot on top of 7 and on top of 2, that means 7, everything in between those two dots are repeating. So this is 0.702, 702, 702, and so on. It keeps on continuing forever. So is it terminating? Not really. If it is not terminating, then there is a chance this won't be a rational number. Then we'll figure out if there is a repeating pattern. If there is a repeating pattern, then it would be rational number. Okay. So this has a repeating pattern, so this is also a rational number. So over here you can see 1 by 3 repeating pattern, so this would be a rational number. Now you might ask, now if all these are rational numbers, what is left for there to be irrational? So basically, if we have a non-terminating decimal and there is no repeating pattern, so for example 0.523693449246 and so on, it keeps on continuing, it doesn't end at 6, it keeps on continuing. This is non-terminating, and is there a repeating pattern? No. So this would be an irrational number. Now this would be irrational number. And if you have square numbers, I hope you guys know what square numbers are. Square numbers would be 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, next 5 squared would be 25, next 6 squared 36, 49, 64, and so on. These are square numbers. So if we have square numbers, if we have these square numbers that you see, and we have their roots, so let's say square root of 9, this actually comes out as an integer 3. This comes out as 3, and we have already discussed all integers are rational numbers, so we can write it in the form 3 over 1. So this would actually be a rational number. But if we have square root of non-square numbers, so for example, square root of, let's say, 15, is 15 a square number? Not really. This would be irrational, because you can put this in your calculator, you'll get a value that would be non-terminating, and it won't have a repeating pattern. So square roots of all non-square numbers, so for example, square root of 8 or square root of 28, these are non-square numbers. There's all their square roots of non-square numbers only. They would be irrational. The most famous irrational number actually is the pi. Although you might say, don't we use 22 by 7 for it? Yes, we do. But that is just an estimate. That is not the exact value. You can Google the value of pi, or you can put this in your calculator. You'll see it would be a non-terminating number. It won't end, and there would be no repeating pattern either. So this is also irrational number. Okay, now if you get a question in the exam that find all the irrational numbers between these two numbers, 2 and 3. So first of all, we'll take square of 2. 2 squared is equal to 4, and we'll take square of the last number, maximum number. 3 squared is 9. So all the irrational numbers between these two numbers, 2 and 3, would be square roots of all the numbers that are between these two, 4 and 9. So basically, square root of 5, square root of 6, square root of 7, square root of 8. These are the only irrational numbers between 2 and 3. All the square root, we just take square of the two numbers, the minimum and maximum, and square roots of all the numbers, all the integers basically between these two, would be your irrational numbers. So let's say they are asking you to find all the irrational numbers between 4 and 5, let's say. So what we do is, this should be simple now. What we do over here is, we take square of the minimum number. The minimum number over here is 4. 4 squared is equal to 16, and we take square of this. 5 squared is equal to 25. All the integers, whole numbers between these two, their square roots, they would be your irrational number. So square root of 17, for example, square root of 18, square root of 19, and square root of 20, 21, 22 till 24, because the maximum is 25, and that would come out as a whole number 5. So we do not include the minimum and maximum. All the square roots or all the integers between these two would be your irrational numbers. Okay, now a question over here. Which of the following are rational numbers? 2 integer, so this is a rational number. This is non-terminating. If it is non-terminating, then we look for pattern. Is there a certain pattern to it? Pattern means repeating. So for example, if it was 0.444 or 0. Let's say 454545, something along those lines, there is no repeating pattern over here. So this is not a rational number. 6.5, all terminating decimals are rational numbers. So this is also rational. You can see if I take 6.5, this can be divided by 1 times 2 times 2. So this would come out as 13 divided by 2. So you can see I wrote 13 divided by 2 over here, and 13 divided by 2 is in the fraction form a over b, where the denominator should not be 0. So this would be a rational number. And this is square root of 3, square root of 2. These are non-square numbers, and their square roots, all non-square numbers and their square roots basically would be irrational. So the only irrational numbers that we have are 2 and 6.5 in this example. So you can see 2 and 6.5. Question number 2, check if below numbers are rational or irrational. First of all, 2, this is rational. We can write it in the form 2 over 1. This is already in the fraction form. This is non-terminating. This is terminating. All terminating decimals, because this ends after 2. All terminating decimals are rational. So 5 by 11 was rational. This is rational as well. And this is also terminating. This is rational as well. All terminating decimals are rational numbers. The only irrational numbers would be, basically one of the example is pi, and square root of non-square numbers, and any number, any decimal with no repeating pattern and that does not end, non-terminating. Okay, now real numbers, it basically includes all irrational fractions, integers, all these numbers. These are your real numbers. Now terminating decimals which end after a certain number of digits. So you can see 7 divided by 8. This basically gives us 0.875. This does end after 3 decimal places, so this would be terminating. So if there are a certain number of decimal places which do end, they would be known as terminating decimals. Now recurring decimals, they never end. So you see 1 by 3 over here. So 0, this comes out as 0.333333 and so on. So recurring decimals would have a repeating pattern like this. We can have, for example, this as well, 137 divided by 259. This would actually give you 0.528957. Then this would start repeating 0.528957. Then again repeats 528957. Then again repeats 528957 and so on. Right? Now even numbers, any number that is fully divisible by 2 with no remainder would be known as an even number. So 2, 4, 6, 8, 132, and when the last digit basically is either 2, 4, 6, 8 or 0, they would be even numbers. Now odd numbers which are not fully divisible by 2, basically you get a remainder when you divide it by 2. So you can see any number that ends with 1, 3, 5, 7, 9 would be an odd number. So you can see a few examples are given over here. Square numbers we have already discussed. So 1 squared, this ends up giving us 1. So this is a square number. 2 squared, 4, this is a square number. 9, 16, 25, 36, 49, 64, 81, 100, 121 and so on. These are your square numbers. Now cube numbers, as the name suggests, I'll just cube the numbers now. 1 cubed is 1, 2 cubed is equal to 8, 3 cubed raised to power 3 basically is 27, 4 cubed is equal to 64, 5 cubed is equal to 125 and so on. These are your cube numbers. Next would be 6 cubed, then 7 cubed and so on. Okay, now this is an important concept which students tend to find or find slightly difficult, and they often get this concept wrong for this particular chapter. So significant figures. So let's say we have 8064 and the examiner asks you to convert this in one significant figure. SF would represent significant figure in this lesson. So if you want to convert this in one significant figure, this is our first significant figure. The first significant starts from, we always in math go from left to right, of course. The first number, first non-zero number would be your first significant figure. So 8 is my first significant figure. When you want to convert to one significant figure, you always look at the next significant figure, which would be 2 in this case, the second significant figure. If you want to convert it in, let's say, 3 significant figures, we look at the fourth significant figure, always the next significant figure basically. So my second significant figure is this 2. Although this is 0, but this would still be counted as a significant figure because we do have non-zero numbers after it. So if I want to convert it in one significant figure, I'll have a look at this second significant figure. If this next significant figure is 5 or greater than 5, I add 1 to the previous digit. If it is not greater than 5, basically less than 5, the previous number remains as is. And for whole numbers, we replace every number, every next number before the decimal with 0. So this being converted in one significant figure would become 8, and then we replace every number by 0, every next number by 0. So the next 3 digits would be replaced by 0. This is converted into one significant figure. So the second significant figure was basically 0, which was less than 5. That is why I did not add 1 to the previous digit. Let's say I get the same question, 8064, but now the examiner says convert this in 2 significant figures. Now I'll have a look at the third significant figure. The third significant, always the next one. So because I want to convert it in 2, so I'll have a look at the third significant figure. So this number, if it is 5 or greater than 5, then I add 1 to the previous digit. So you can see this is greater than 5, 5 or greater than 5. So I'll add 1 to the previous digit. Previous digit was 0, so this becomes 1. So 8, 1, and I replace every next digit before the decimal with 0. So 8100. This would be the answer. If I take the exact same question, let's say 8064, but now the examiner asks me to convert this in 3 significant figures, let's say. Now I'll have a look at the next significant figure, which will be the fourth one. This is the fourth significant figure. This is less than 5. So previous number remains as is. So 806, and I replace every number after it before the decimal with 0. So this would become 8060. This would be this converted in 3 significant figures. Okay, the examples have been given over here, and let's do another example. Let's say we have 0.00208, and the examiner tells us to convert this in one significant figure. Now the zeros on the left side are not significant. The significant figures always start from the first non-zero number. The first non-zero number is this 2. So I'll have a look at the next significant figure, the second one, which would be this 0 over here. This is less than 5. If it is 5 or less than 5, it is less than 5, not equal to 5, because if it is equal to 5, then we add 1 to the previous digit, 5 or greater than 5. If it is less than 5, then the previous number remains as is. But the important point to note over here is 0.002. We do not replace the next digits by 0. I will not write 0.00200, because this would actually become 3 significant figures. The reason being, in decimals, even if you have zeros at the end, they are counted as significant. For whole numbers, that was not the case. They may or may not be significant for whole numbers. But for decimals, even if you have zeros at the end, they are definitely significant. So if you write this, this would be marked incorrect. You actually need to write 0.002. That's it. This is one significant figure. So this is this written correct to one significant figure. So let's say if I take the exact same 0.00208, and the examiner tells me to write this correct to, let's say, 2 significant figures. So the first significant figure, of course, is this 2. The next significant figure is this 0. So I'll have a look at the third significant figure, because I need to convert it into. So the third significant is 5 or greater than 5. So I add 1 to the previous digit. So this becomes 0.0021. I will not write 0 at the end. If I write this, this would be converted in 3 significant figures, which would be marked incorrect. So this would be my final answer. I hope this made sense. Another example, 3.00508. And let's say the examiner tells us write this correct to 2 significant figures. So my first significant figure actually starts from here, and my second significant figure is this 0. So I'll have a look at the third significant figure, because I need to convert this in 2 significant figures. So I'll have a look at the third significant figure. Third significant figure is 0. So I will not add 1 to the previous digit. The previous digit remains as is. This would become 3.0. I will not write 0 after it, because it would be considered 3 significant figures. The zeros at the end, even after decimal, would be considered significant. This would be my answer. If I have another question, let's say I have a 0 point, or rather, let's take this example over here, 3.00508, and now the examiner tells me to convert this in 3 significant figures. Okay, now I'll have a look at the fourth significant figure. Significant figures start from this 3 over here, 1, 2, 3. Now I have a look at the fourth one. If it is 5 or greater than 5, I add 1 to the previous digit, which this is 5 or greater than 5. So plus 1 to the previous digit, 3.01. This is 3 significant figures. If you replace the next 508 with zeros, it would convert into 6 significant figures. That would be marked incorrect. So the main concept over here is, if we have zeros even after decimal, even at the end, they would be considered significant. But for whole numbers, the numbers at the end, they are insignificant. In most cases, they can be sometimes significant as well, but in most cases they would be not significant. But for decimals, if you have zeros at the end, they are 100% significant. Let's take another example. Let's say I have 3.00, and let's say 5, and then I have 976, and the examiner tells me to convert this in 5 significant figures. Okay, now first of all, I'll count the significant figures 1, 2, 3, 4, 5. This is the fifth one. So I'll have a look at the next significant figure. You see, this is 7. So I'll have to add 1 to the previous digit. But when I add 1 to the previous digit, this 9 becomes 10. So that I can't do. So what I'll do in that case is I'll actually look at the last two numbers. So I'll have a look at the last two numbers. The last two numbers combined, they are basically this one gets carried to the previous digit. This would become 10, but that 1 would actually be carried over here. So this 5 would become 6 and this 9 would become 0. But the easier way maybe could be you can look at the last two digits combined. This is 59, so this would basically become 60. So this becomes 3.0060. Now let's count 1, 2, 3, 4, 5. 5 significant figures. This would be the answer. So if you have 9 as the previous digit, just look at the last two then. And if even the previous digit, let's say this 5 was also 9, then you look at the last three digits and so on. I hope this made sense. Now decimal places are similar to significant figures. Let's say we have 0.0647 and the examiner tells you to write this correct to one decimal place now. Now my first decimal place would always be after the decimal. This is one decimal place. Now because this is one decimal place, I'll have a look at the next decimal place, which is the second one. This is 6. Because this is 5 or greater than 5, I add 1 to the previous digit. So this becomes 0.1. We leave it off here because we need to write it correct to one decimal place. So let's say I have 0.0647 and they ask us to write this correct to two decimal places. So over here, my second decimal place is this 6. I'll have a look at the next one, the third one. This is 4. This is less than 5. So the previous digit remains as is, 0.06. We leave it off here because this is two decimal places. If I get the same question, 0.0647, but the examiner tells me to write this correct to, let's say, 3 decimal places. The third decimal place is this 4. I look at the next one, 4 decimal place. This is 7. So I add 1 to the previous digit. So this becomes 0.065. This is the final answer. Now another question, 2.0647, and let's say the examiner tells us to write this correct to 3 decimal places. Now this 2 is irrelevant. This is not a decimal place. Decimal places always start after the decimal. This is one decimal place, 2 and 3. So we'll have a look at the fourth one because we need to convert it in 3. So this is 7, which is 5 or greater than 5. I add 1 to the previous digit. This becomes 2.065. This becomes my final answer. I hope this made sense. Now we'll go to a few past paper questions and let's see if you guys understood these. But before we move on to past paper questions, let's just do this one last concept, the prime factors. Let's try to find, let's say the question was find prime factors of 99. So what we do in this case is just like the LCM method. Basically we just take one number, this 99, and we just try to find the lowest number for which like basically the lowest factor of 99. So we'll look for even numbers, as in for 2 first. If we have an even number, we can divide it by 2 first, but that is not the case. So 99 divided by 3 would actually be 33. Now once again I can take 3. Now 33 divided by 3 would be 11. I can directly take 11 because 11 is a prime number. Because as the name suggests, we are looking for prime factors only. So we can only utilize prime numbers. So we can't take, for example, 4 or 6 or 8 because those are not prime numbers. So yeah, at the end we just write our answer as 3 multiplied by 3 multiplied by 11, because when you multiply all these you actually get the same as the question, which is 99. So we just leave it off as this. But you can also write this in a neater format because we have 2 3's. So I can write 3 squared times 11. This can be my final answer. This is how we find prime factors. Another question that can arise, for example, find LCM, least common multiple of, let's say, 8 and 12. So we make a table just like we did for HCF, but there is one subtle difference. So I'll look for the smallest, both are even numbers, so I can take 2 for example. 8 divided by 2 would be 4, 12 divided by 2 would be 6. Once again I can take 2, both are even numbers. 4 divided by 2 would be 2, 6 divided by 2 would be 3. Now for HCF we left it off here. We just did 2 multiplied by 2, that was 4, that was the HCF. But for LCM we continue till we have 1 and 1 on the right side over here. So now I'll take 2. So even if one of the number is fully divisible, we continue for LCM. For HCF, all the numbers must be fully divisible by that particular number. Otherwise, we can't continue. So this becomes 1 and this becomes 3. Now I'll take 3. This becomes 1 and this becomes 1. Now I can leave it off here and I'll just multiply these numbers. 2 times 2 times 2 times 3. 2 cubed would be 8. 8 multiplied by 3 would be 24. This is our LCM. This is how we find LCM. Okay, now we can move on to past paper questions. Now we'll focus on the past paper questions of the chapter numbers and accuracy. Now let's start with the first question. Okay, now you see this question over here, question number 1. So from the list of numbers, write down a cube number. A cube number would be like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, something along those lines. So if you find 7 cubed, that would actually be equal to 343. So this is actually a cube number. None of the others is a cube number. 343. Cube number, of course, would always be a whole number. So we are just looking for positive whole numbers basically. And we only have this one. The smallest number. The smallest number is actually the number in negative. In case we have any negative number, the bigger the number, the smaller it is. So in negative, we actually have two numbers, -7 and -11. So -11 is bigger. So that would be smaller. A natural number, so we are basically looking at a positive whole number. We only have one positive whole number, and that number is 343. So this should be the answer for C part. Question number 2. One day at noon, the temperature was 17 degrees Celsius. At midnight, the temperature was 20 degrees lower. Work out that temperature. Basically, lower means just subtract it from 17. So 17, take away 20, 17 minus 20 basically. This gives you -3 degrees Celsius. So -3 degrees Celsius. So I'll just write it over here. Okay, now next, question number 3. 1 and 12 are factors of 12. Write down all other factors of 12. So 1 and 12 they have already written, so we don't necessarily need to write them down. So 2 times 6 would be 12. So 2 is a factor. 3 times 4, 4 times 3, so 4 is a factor as well. 5 no, 6 yes, and next would be 12. So we just needed to write these 4 because 1 and 12 are already written. Write down the multiples of 9. Multiple means times table between 20 and 40. So I'll just do the rough working over here. 9 times 1, 18, 27, 36, 45, and so on. These are multiples of 9. They're specifically asking us between 20 and 40. So that would be this number, 27 and 36. 27 and 36. So 27 and 36, this would be my answer. Okay, now write 23.4571 correct to 4 significant figures. So my fourth significant figure is this 5. I'll look at the next significant figure. This 7 is my fifth significant figure. So I'll have a look at this. Is this 5 or greater than 5? If yes, then I add 1 to the previous digit. And as you can see, it is greater than 5 or greater than 5. So I'll add 1 to the previous digit. So this 5 would become 6. So basically this becomes 23.46. This is the answer. Next, write this correct to the nearest 10. So I'll write it in multiples of 10. So for example, 10, 20, 30, 40. So we have 23. Is it closer to 20 or 30? This is 23 is closer to 20. Right? So 20 should be the answer. Next, the table shows temperatures in 5 places at 10 a.m. one day in January. Which place was the coldest? They specifically told us place, right? So we need to give these as an answer. The place. We don't need to write temperature. Coldest would mean the in negative and the biggest number in negative. The biggest number in negative is -10 that you see over here. So I need to give its place, which is Chicago. Chicago. I need to write the place, otherwise I won't get the mark. At 2 p.m., the temperature in Helsinki had increased by 4 degrees. So this would be plus 4. Write down the temperature in Helsinki at 2 p.m. Helsinki, the current temperature is minus 7. So minus 7 increased by 4 plus 4. This would be minus 3 degrees Celsius. This is the answer. Write this correct to two significant figures. First significant figure is this 7. The zeros on the left are not significant, and the second significant figure is this one. So I'll have a look at the third significant figure. My third significant figure is this 6. If this is 5 or greater than 5, I add 1 to the previous digit. So this is greater than 5, so I'll add 1 to the previous digit, so this becomes 0.072. Answer. Write down the temperature which is 5 degrees Celsius below minus 2. Below means subtract. So minus 2 and minus 5. 5 degrees below it. So this becomes negative 7 degree Celsius. Basically, minus 2 take away 5. Next, 0.041907 correct to three significant figures. First significant figure is this 4. Second significant figure is this 0. Then third significant figure is this 1. This is the fourth significant figure, 9. So this is my fourth significant figure. Now I'll have a look. If it is 5 or greater than 5, then I add 1 to the previous digit, and it is greater than 5. So this 1 would become 2. I add 1 to the previous digit. So this basically becomes 0.0402. This is the final answer. Next, they are saying 3 decimal places. Now my first decimal place actually starts from this 0 over here. This is my first decimal place. Now second is this 4. The third is this 0. So I'll have a look at the fourth decimal place. The fourth decimal place is actually this one. This is less than 5. So previous number remains as is. So we will do nothing to the previous number, and we just write 0.040. This is 3 decimal places, 0.040. This is the final answer. Okay, this is related to indices. We haven't started it yet, but when you have the same bases, which is the case over here, both are n's, and you have multiplication in between, basically we add the powers. N raised to power 2 plus 5, the answer would be n raised to power 7. We add the powers when there is multiplication in between, and as long as the bases are same. Okay, find the LCM of 36 and 48. So I'll just find it over here. 36, 48. So we'll start off with the lowest number, 2. This would be 16. 36 divided by 2 would be 18. This is 24. Now we can take 2 again, even numbers. This would become 9, and this would become 12. Now I can take 3. This would become 3. This would become 4. I have to continue for LCM. 3, this becomes 1, and I'll just directly take 4, or you can take 2 and 2 as well. Either way, you get the same answer. So now I just need to multiply all these numbers which are on this side. So 2 times 2 times 3 times 3 times 4. When we multiply all these, I think we get 144. This should be the answer. Question number 11. Write this correct to 4 significant figures. First significant starts from this 3. Now my fourth significant figure would be this 9. Now I'll look at the fifth significant figure, which is this 7. So if it is 5 or greater than 5, then I add 1 to the previous digit. So I do need to add 1 to the previous digit, but you can see this is 89. This is 9. So when I add 1 to the previous digit, 9, it becomes 10. So that 1 carries to the previous digit, 8. So it would be 8 plus 1. So it becomes 9. Or you can have a look at the last 2 digits combined, 89. This would become 90. So this becomes 3.590. You need to write the 0 at the end. If you don't write the 0, because sometimes the students just write 3.59. That is 3 significant figures. You need to write correct to 4 significant figures. The 0 at the end is significant after decimal. So this is 4 significant figures. This is the answer. From the list, write down square numbers. So square numbers are basically 1 squared is equal to 1, then 2 squared is equal to 4, 9, 16, 25, and so on. So we are looking for square numbers over here. You see we have 9 over here, and we have 16 over here as well. So 9 comma 16. Prime factor of 99. We actually did this during the lecture. How do you find the prime factors? This would be we only can only just like taking LCM of a single number. So, but we can't use even the only even number that we can use is 2. We can't use non-prime or composite numbers basically. So I'll write 3 over here. This becomes 33. 3 again. This becomes 11. This now I can take 11. This becomes 1. These are the prime factors, 3 and 11. So do we have any 3 here? Not really. But do we have 11? Yes, we do. So I'll just write 11 over here. Okay, we have 71,496 correct to two significant figures. So the second significant figure is this one. So I'll have a look at the next significant figure, which is this 4. If it is 5 or greater than 5, I add 1 to the previous digit. Otherwise, I don't. This is less than 5. So this becomes 7, 1. But I need to replace all the next numbers with 0, because in whole numbers, the zeros at the end are not significant. But in decimals, they are. They may or may not be significant, but in most cases they aren't for whole numbers. So we'll just take standardized not significant. So 71,000. If you write just 71, that would be incorrect. Find the HCF of 56 and 70. So 56 and 70. Let's start with 2. This should be 28. This should be 35. Now I can take 7. 7 4 times is 28 and 5 times is this. We can't go any further because this is not LCM, this is actually HCF. If there is nothing common in the numbers, we don't continue further. So we'll just leave it off here. We'll just multiply these two. 2 times 7 would be equal to 14, which is our answer. Okay, now question number 15. Write 2016 as a product of its prime factors. So how do we solve prime factors? Just like taking LCM of a single number, 2016. I'll start off with 2 because this is an even number. This becomes 1008. This is also an even number, so I can do with 2. 504. Again with 2. 252. Again even number. I can take 2. So this becomes 126. Once again 2. This becomes 63. Now this is not an even number, so I can take 3 now. This becomes 21. Now again I can take 3. This becomes 7. Now I can take 7. This becomes 1. I'll just write all these numbers. Basically this would be 2 times 2 times 2. So basically this would be 2 multiplied by 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 3 multiplied by 3 multiplied by 7. We don't have to multiply them and write that because this will actually give us 2016. So what we need to do over here is we have 5 2, so 2 raised to power 5 multiplied by 3 raised to power 2. We have 2 3's multiplied by 7. This becomes our final answer. Now in the next part they are saying write 2016 in standard form. Although we haven't done standard form yet, but basically if there is no decimal, then the decimal is right at the end, 2016.0. Basically this is like this. Decimal is at the end. We need to bring this decimal after the first non-zero number. First non-zero number is 2. So decimal has to be brought over here. So I bring it over here, 1 place to the left, 2 places, 3 places. We are bringing it 3 places to the left. So this becomes 2.016, and the number of places we bring to the left, we just do multiplied by 10. And if you are bringing it to the left, then it would be positive 3. If you are bringing it to the other side, then it would be negative. So this would be the answer. Next, at midnight the temperature was minus 8 degrees Celsius, and at noon the next day the temperature in Newtown was 9 degrees Celsius. Work out the rise. We can just make a timeline, I guess. Minus 8, and the maximum at 9 we have 8. Just take a few jumps till you get positive 9. So let's say we take a jump of 8. So if we take a jump of plus 8, so we'll have 0 over here, and now we just need to take a jump of 9. So you can see 9 plus 8 should give us the answer when we go from negative 8 to 9 basically. So the difference is 17 degrees Celsius. You can also do like final minus the initial. So this would be in a bracket. Minus multiplied by minus becomes plus. So 9 plus 8 is equal to 17. So either way we get the same answer. Okay, now we'll move on to the next worksheet, the second worksheet of numbers and accuracy. So this is the second worksheet of numbers and accuracy. Okay, so let us get started. By writing each number correct to one significant figure, estimate the value of this. So we need to convert all these in one significant figure. So the first one is 3.9. So 3.9, my second significant figure. All of them, I'll have to look at the second significant figure. This is my second significant figure, which is 5 or greater than 5. So I add 1 to the previous digit. So this would become, this 3 would become 4. I cannot write 4.0 because this 0 at the end after decimal is significant. You actually need to write just 4. If you write 4.0, that would be marked incorrect. You lose 1 mark. This is worth 2 marks, and 1 mark is just for the working. Next is 29.3. My second significant figure is this 9. So because this is greater than 5 or greater than 5, I add 1 to the previous digit. This becomes 3. Every number before decimal would be replaced by 0. So this 9 is before decimal. So this becomes 0. Now next, 8.9. So once again, this is 9, 5 or greater than 5. Previous number increases by 1. So I'll just write 9. This would not be 9.0. Another number is 2.7. This is 5 or greater than 5. I add 1 to the previous digit. So this becomes 3. Do not write 3.0. Now that I have these numbers, I'll just write them. I'll replace them over here. This becomes square root of 4 times 30 divided by 9 minus 3. Now square root of 4 ends up giving us 2 multiplied by 30 divided by 9 minus 3 would be 6. 2 times 30 would be 60. 60 divided by 6. We can cancel these two out. This would be 1 times of 6. This would be 10 times of 6. So at the end we get 10 as our final answer. Question number 2. HCF of 36 and 90. We'll start off with 2 over here. This becomes 18. This becomes 45. Not even number, so 2 is out. 3. This is 6 times. This would be 15 times. Once again 3. This would be 2 times. This would be 5 times. We can't continue any further because for LCM we do continue. Otherwise for HCF, unless there is common, then we stop. So 2 multiplied by 3 multiplied by 3. 2 times 3 would be 6 times 3 would be 18. This becomes our final answer. This is our HCF. Work out the difference between these two temperatures. So minus 9 and then difference I'll write, or you can write, you can make a timeline as well. Basically you can do either bigger number minus smaller number, or you can just make a timeline. 8 comes over here and minus 9 over here. So you can see if I take a jump of 9, I reach 0. Then I take a jump of 8, I reach plus 8. So this would just be 9 plus 8, 17. So this was a jump of 9 over here. Just write it again. So that way we get our answer. So this is the difference between these two. Write this correct to two significant figures. So my third significant figure is this 8. This is 5 or greater than 5. So I add 1 to the previous digit. So I write 6 becomes 7. But this is not the final answer. Every number before decimal has to be replaced by 0. So I need to write 0 over here. Otherwise this would not be correct. 170 becomes the final answer. Next we have a list of numbers. Which numbers are factors of 60? So over here we'll just look at this list. You see 12. Is this is 60 in its table? 12 times 5 would be 60. So 12, yes. Not in 11, not in 13, 14 either. 15, yes. 15 times 4 would be 60. So I'll write 15 as well. So these are the factors, 1 and 12 and 15. Okay, now the prime numbers. Prime numbers from this list would be 11. It only has two factors, 1 and 11, and 13 as well. For even numbers, you don't even have to look at 12, 14, 16. And for 15, we have 5 as well, which is a multiple. 15 comes in its table. So why do we not look at even numbers? The only prime number for even numbers is 2. So this should be the answer. Work out the difference in temperature between midnight and this. So basically what we can do is minus 5.5 over here and then 4 over here. I can first take a jump of 5.5, so this becomes 0, and then I can take a jump of 4. So 5.5 plus 4 actually gives me 9.5. So this should be the answer. Write 30 as a product of its prime factors. So 30, just take LCM of a single number. So we can only use prime numbers. This becomes 15. Now 3, this becomes 5. Now 5, this becomes 1. So I just need to write these numbers: 2 times 3 times 5. 2 times 3 times 5. This is the answer. Now next we need to take LCM of 30 and 45. 30, 45. I can start off with let's say 3. This is 10. This is 15. I can take 5. This is 2 times. This is 3 times. LCM. So we continue 2 and this becomes 1. 3. This becomes 1 comma 1. So I just need to do 3 times 5 times 2 times 3. When I multiply all this, I should get 90 as my answer. For the next one, LCM of 24 and 32. 24 and 32. I can start off with 2. This becomes 12, 16, once again 2, 6, 8, once again 2, 3, 4, once again, now 3. I continue because this is LCM 1 comma 4. Now I can just directly take 4, 1 comma 1. So 2 multiplied by 2 multiplied by 2 times 3 times 4. So when I multiply all this, I should get 96 as my answer. This should be my LCM. Now write this correct to one decimal place. My first decimal place is this 0. I'll have a look at the next decimal place. So 7 is my next decimal place, the second decimal place basically. If this is 5 or greater than 5, then I add 1 to the previous digit, which it is. So 7 is greater than 5, so I'll add 1 to the previous digit. This becomes 15.1. Now nearest 10, tens would be like 10, 20, 30, 40. 15, is it closer to 10 or 20? Because this digit is 5, so we basically round it up upwards. So this is closer to 20 than 10. So 20 would be the answer. Okay, insert one pair of brackets only to make the following statement correct. So basically we need to do trial and error over here. Maybe we can put brackets over here, then do the calculation. If it is equal to 16, then this would be the bracket. 6 plus 5 would be 11 times 10. This actually gives us 110. Then we do minus, we need to use the BODMAS. So we'll do the multiplication first. 110 minus 8, this won't be equal to 16. Next, we can put brackets somewhere. Maybe we can put brackets over here. So this we always solve the brackets first. 6 plus 5, and in the bracket 10 minus 8 brackets first, this becomes 2. Now 6 plus, we'll solve the multiplication first, BODMAS. Multiplication is done before addition. This becomes 10. 6 plus 10 would be 16. So you can see if I put the bracket over here, between 10 and 8, that would be the correct answer. So I can just rub this off. This is the answer. Okay, now write 90 as a product of its prime factors. So 90 over here. Now just do kind of like LCM. Only we can only use prime numbers. So this becomes 45. So we can do 3 over here. This becomes 15. I can use 5. This becomes 3. I can use 3. This becomes 1. So we have 1, 2. So 2 times, and we have 2, 3. So 3 raised to power 2. And we have 1, 5. So 5 multiplied by 5. So this is the answer. Now find least common multiple, or basically LCM of 90 and 105. So 90 over here, 105 over here. Let's try to find this. Maybe I can take 5. So this would be 18 times, and this would be 21 times. I can take 3. This would be 6. This would be 7. I can take 6. I continue because this is LCM 1. This would be 7. I take 7, 1 comma 1. So I just need to do 5 times 3 times 6 times 7, and when I multiply these, I think I get 630. So this should be the answer. Okay, now in the spaces provided, write each number. First, write it correct to one significant figure. So this is 4.8. The second significant figure is 8. 8 is greater than 5, so I add 1 to the previous digit. So 4 becomes 5. I do not write zero point 0 because that would be two significant figures. Now multiplied by 1.9. The second significant figure is 9. This is greater than 5. I add 1 to the previous digit. So 1 becomes 2. So I'll just write 2, not 2.0. And in the denominator, I have 6 over here as the second significant figure. This is 5 or greater than 5. I add 1 to the previous digit. This 1 becomes 2. But I need to replace every number before decimal with 0. So 6 is before decimal. So this has to be replaced by 0. So this would be it. Now in the next part, I actually need to solve this. 5 times 2 would actually be 10. I'm just solving this part over here. And divide by 20. We can cancel out the zeros. This 0 cancels out with this. 1 divided by 2. Or you can write 0.5 as well. This is the answer. Now write this correct to two significant figures. Now my second significant figure is this 6. I'll have a look at the next significant figure, which is 9. If it is 5 or greater than 5, I add 1 to the previous digit. So this is greater than 5, so I'll be adding 1 to the previous digit, which was 6, so it becomes 7. So 5, 7, and I replace all the numbers before decimal with 0. So this 9 has to be replaced by 0, and we have 3 zeros already at the end, so this would be the answer. Now they are saying write this in standard form. So the decimal would be at the end. We need to bring the decimal after the first non-zero number. So we need to bring it after 5. Let's see, 1, 2, 3, 4, 5. 5 places to the left. So we just write 5.69. We need to write the regular numbers apart from 0. So 5.69 multiplied by 10 raised to power. This would be in positive because we are moving to the left. So positive 5. We moved 5 steps to the left. That's the reason. Now next, in March 2011, the average temperature in Kiev was 3 degrees Celsius. In March 2012, the average temperature in Kiev was 19 degrees lower. So it was 19 degrees lower. So we just need to subtract 19 from 3 to find the final answer, which would be negative 16 degrees Celsius. Okay, now next we are moving to the third worksheet of numbers and accuracy. Now we are moving to the third worksheet of numbers and accuracy. Let's start this third worksheet. Okay, now give your answer correct to 4 significant figures. So we need to calculate this. We actually need to put this in our calculator. Calculator is allowed for this particular question. We need to put this value in our calculator, and whatever we get, we first write the whole thing. And after writing the whole thing, we need to convert that answer into 4 significant figures. So let me just check what we get. Let me check what we get. I think we get, just give me a second. I'll have to put this in my calculator. 5.27, take away 0.93. I go in the denominator, 4.89. Take away 4.07. I get 5.2928 and so on. So I need to convert this in 4 significant figures. This is my 4th significant figure. I'll have a look at the 5th one. This 5th one, you can see, is 6, which is 5 or greater than 5. I add 1 to the previous digit. So this becomes 5.29. This 2 becomes 3. This is the final answer, 4 significant figures. Next, on 1 January day in Munich, the temperature at noon was 3 degrees Celsius. At midnight, the temperature was -8. Work out the difference between the two. So -8 over here and 3 degrees Celsius. The difference between these two, I'll just take a jump of 8 first so that I reach 0. And from there, I just need to take a jump of +3. Now you see the difference, 8 plus 3. I took a jump of overall 11 degrees Celsius, +11. Okay, next question. The sum of prime numbers less than 8 is equal to 17. I'll just write all my prime numbers which are less than which are less than 8. So for example, 2 is a prime number, 3, 4 no, 5 yes, 6 no, 7 yes. So 5 and 7. They specified less than 8. So we do not include 8, and it is not even a prime number. So when I add all these, 2 plus 3 is 5, plus 5 would be 10, plus 7 would actually be 17. So this gives me plus 17 plus 17. Now find the sum of prime numbers less than 21. So I already have this list. Now I'll find the numbers which are more than 7, the prime numbers which are bigger than 7. Ignore the even numbers. I'll only look at the odd numbers. The only even number which is a prime number is 2, which is already done. Next would be 11. Then we have 13 as well. This is less than 21. So 15 no, 17 yes, 19 yes, and they specified less than 21, so that's it. So I need to add all these, and I think when we add all this, we actually get 60. This is 60, but this is just the addition of these numbers. They specified find the sum of the prime numbers less than 21. So we already had 17 for these four numbers, right? So we actually need to add these as well. So just do 60 plus 17, and that actually gives us 77. This would be the answer. Now in B part they are saying the sum of prime numbers less than x, we do not know this number x, is 58. Find the integer value of x. So less than a certain number. So I'll keep on adding these numbers starting from 2, of course. This is the smallest prime number. So 2 plus 3 is 5, plus 5 is 10, plus 7, this is 17, plus 11. I'll keep on adding these now. 17 plus 11, then plus the next one is 13, so I'll add plus 13, which is 41. Now I'll add the next one, which is 17, so plus 17. This is equal to 58. This is equal to 58. Now till 17, this is equal to 58. Now they specified less than x. So can I write 17? Not really, because this should have been equal to x, equal or less than. So because there is no equal to, I need to take a number that is bigger than this. So I can either say, for example, 18, or I can say 19 or as well. So I'll just say x is equal to 18. If you write 19, that would be an acceptable answer as well, because 18 is not even a prime number. So you can write 18 or 19, both would be acceptable. Okay, now you can ignore this. This is not part of this chapter. Next, we'll write the following number correct to one significant figure. So I'll have a look at the second significant figure. This is 5 or greater than 5. So we add 1 to the previous digit, it becomes 8. And then we do need to replace all the numbers before decimal with 0. So 0, 0, 0. Next, I need to write this correct to one significant figure. Have a look at this number, 6. This is 5 or greater than 5. So I add 1 to the previous digit. This becomes 0.08. Right, this correct to one significant figure. So the second significant figure is 6. So I'll add 1 to the previous digit. This becomes 3. We do not write 3.00 because that would be 3 significant figures. Now multiplied by 4.1. This is 1. So this is less than 5. So previous number remains as is, 4. And then plus 7.9. This is 9. So this is 5 or greater than 5. I add 1 to the previous digit. This becomes 8. Now we need to do the BODMAS. We need to do the multiplication first. This would be 12 and 12. Then we add 8 in it. This becomes 20. This should be the answer. Next question. Okay. Now in this particular question, they are saying P is the largest prime number between 50 and 100. So we'll just go backwards from 100 because we are looking for the largest prime number. Is 99 a prime number? We'll only look for odd numbers because even numbers, only 2 is a prime number. 99, no, it comes in the table of 9 as well as 3. That is out. The next odd number would be 97. So 97. Is it a prime number? Yes, it is. Yes, it is. So the largest prime number should be 97. and q is the smallest prime number. So we'll start off from 50, and we only look at the odd numbers. 51, no, it is in the table of 3. That is out. Next is 53. 53, yes, 53 is a prime number, so this should be 53. So now I just need to do p minus q. P is 97 minus q is 53. This gives me 44 as my answer. Next, write down the next two prime numbers after 43. 45 is in the table of 5, that is out. Next, odd number 47. 47, yes, it is a prime number. And 49, no, because this is in the table of 7. And 51, no, table of 3. Then 53, yes, 53 is a prime number. These are the next two prime numbers. Write down the next two prime numbers after 47. So we already found 53. So I'll just continue from there. 53, and the one after 55, no, this is a multiple of 5. Next would be 57, no, table of 3. 59, yes, 59 is actually a prime number. So this would be the answer. Next, write the number 1045.2781 correct to two decimal places. Now second decimal place is this 7. So I'll have a look at the next decimal place. This is 8, third decimal place. If this is 5 or greater than 5, I add 1 to the previous digit, which I need to add to the previous digit because 8 is greater than 5. So this becomes 1045.28. This should be the answer. Now, two significant figures. My first significant figure is this one. My second significant figure is this 0. Because we do have 4 and 5 after it, so this 0 would be considered significant. So I'll have a look at the third significant figure, which is this 4. If this is 5 or greater than 5, I add 1 to the previous digit, otherwise I don't. So this is less than 5, so previous digit remains as is. This would be 1 0, and I need to replace every number before decimal with 0. 1 0 0 0, so 1000. Write down an irrational number. This can have multiple answers. So for example, you could have written pi, or basically you can write any non-square number inside the root. So for example, square root of 2, or let's say square root of 8, or let's say square root of 15. It should be a non-square number, a prime number between 61 and 70. 61, yes, 61 is a prime number. So you can write it only has two factors, so 61 is a possible answer. I think 67 would be a possible answer as well, so just write one. Write down the next prime number after 89. Ignore even numbers. 91 is in the table of 7, so 91 is out. Then 93 is in the table of 3. 95 table of 5. 97, yes, already did a question in which 97 was a prime number, so 97. Okay, now next, calculate the range. The formula for range, although this will do in statistics as well, range is basically equal to highest value minus lowest value. Highest value minus lowest value. So I just need to calculate the range. The highest value, positive biggest number, which would be 350, minus the lowest number would be negative biggest number, minus 220. So minus times minus becomes plus. 350 and plus 220. Actually, we do have 240 as well. Apologies. We do have 240 for Pluto. So this should be 240 rather than 220. You can see 240 is there. I just directly took Neptune value. So I'll have to replace this with 240. So this becomes 590 degrees Celsius. Okay, now next, which planet has a temperature 20 degrees lower than Uranus? Uranus is minus 220 degree lower. So basically minus 200 minus 20. So you can see minus 220. So this would be, they are looking for the name of the planet. So if you just write minus 220, that won't be the answer. You will get 0 marks. They specified which planet. So you need to write the name of the planet, which is Neptune. Now write this, write the number this correct to three significant figures. So you can see this is my third significant figure. I'll have a look at the next one, which is this one, fourth significant figure. If the previous number, if the next number The fourth one, if it is 5 or greater than 5, I add 1 to the previous digit, otherwise I don't. So over here I won't, because 1 is less than 5. So this becomes 2 3 8, and I need to replace every number before decimal with 0. So only 1 0. Now two decimal places. For two decimal places, you see this is my second decimal place. This number 9 that you see, this number 9 is my uh, second decimal place. After it, I have 7, which is 5 or greater than 5. I add 1 to the previous digit, but because this is 9, I'll just have a look at the last two digits combined. 59 plus 1 would be 60. So I do need to write 23.81.60. If you just write 6 and not 0 at the end, that would just be one decimal place. So you won't get marked for it. You need to write the 0 at the end, otherwise it won't be two decimal places. Now next, they are saying the nearest 100. Hundreds would be like 100, 200, 300. So over here, 2300 or 2400. This is closer to 2400. 381 basically is closer to the 400 mark. So 2400 should be the answer, nearest 100. Next, over here we have these values. Write down one integer value, basically whole number. We are looking for a whole number. 65 divided by 13. So this is actually equal to 5. So 65 divided by 13, and we also have square root of 16. This ends up giving us 4. So you can write square root of 16, or you can also write 65 divided by 13. Both would be marked correct. Next, one irrational number. So square root of non-square number. So this is irrational. Pi is also irrational. So either you can write pi, or you can write square root of 40. Okay, now next question. By how many degrees did the maximum temperature change between Thursday and Friday? Let's have a look. Thursday and Friday. So this is this is plus 2.5, and this is minus 1.5. So the difference is basically 4 degrees Celsius. So basically what we need to do is 2.5 minus difference. That is why we have minus there. We need to calculate the change, and minus 1.5. So minus times minus becomes plus 2.5 plus 1.5. You can make that timeline as well. Highest and lowest value, just take a few jumps to reach your final, and that will be 4 degrees Celsius in that method as well. What is the difference between the greatest and the least of these temperatures? So biggest temperature in positive, highest, that would be this 3 degrees Celsius. In negative, the lowest, that is minus 1.5. So 3 minus, this is because of the difference, and now I need to put minus 1.5 in a bracket, minus 1.5. So this becomes 3 minus times minus is plus 1.5 is equal to 4.5 degrees Celsius. This is the answer. Okay, now we'll do the last worksheet of numbers and accuracy. This would be the fourth worksheet of numbers and accuracy. Let us get started with the fourth worksheet. And hopefully this would be the hardest of the lot. LCM of 20 and 24. So 20 comma 24. LCM over here, I can take 2 first. 10, 12, once again 2. This becomes 5. This becomes 6. 5 over here, 1 comma 6. This becomes 6. 1 comma 1. I just need to do 2 times 2 times 5 times 6. I think this gives us 120 if I'm not wrong. Okay, now write this correct to one significant figure first. We need to convert all this into one significant figure and then estimate the value. So I'll convert this in one significant figure. This second significant figure is 0 for this 10.3. So this is 0. So previous number remains as is 1. And I do replace every number before decimal with 0. So 10. Then I have multiplied by second decimal place is 9. So previous number has to increase by 1. So this becomes 2. Every number before decimal has to be replaced by 0. So I'll write 1 0 after 2. Now this is my second significant figure is 8 over here. So previous number increases by 1, 9. And every number before decimal has to be replaced by 0. So 9 0. Minus this is 3. So this is less than 5 now. So previous number remains as is, and we replace every number before decimal with 0. Okay, now 10 times 20 would be 200, divided by 90 minus 40 would be 50. I can do the cancellation, or you can directly do as well. 200 divided by 50 would actually be 4. So 4 is my final answer. Okay, this is from a different chapter. This as well, so we'll ignore these. The ones which are from a different chapter, we'll just focus on numbers and accuracy. This is just a typo. This is 211. From the list of numbers, find a prime number. So we are looking for prime numbers over here. Um, we have 211. Even numbers can't be prime numbers. So 210, 212, 214, 216 are out. 215 is in the table of 5, that is out as well. 213, this is in table of 3. So the only option left, 211, this would be a prime number. Now next, a cube number. So basically, if you look at 6 cube, that should be equal to 216. We do have a 216 over here, so 216 should be the answer. That is a cube number. Which of the following are irrational? This would basically be 6, and 6 can be written as 6 divided by 1. This combined, this is irrational because this doesn't become a square root of a square number. This entire thing, this would be irrational. Pi, this is also irrational. This is terminating. So terminating decimals are actually rational numbers. 48% percent means divide by 100. Basically, this would be 48 divided by 100. This is rational as well. 8 raised to power 1 by 3 would actually be 2 raised to power 3 multiplied by 1 by 3. Although we will do this in indices, this gets cancelled out. Basically, this would end up giving you 2. You put this in your calculator as well for now, and this can be written in the form 2 divided by 1. So this would be rational as well. So we are just looking for only irrational numbers. So the only irrational numbers for us are this and this. This would not be an irrational number. So I'll just write square root of 3 plus square root of 6, and the second one, pi. This is where 2 marks. You need to write both to get both marks. Okay, now standard form, we need to bring the decimal 1, 2, 3, 3 places to the right after the first non-zero number, which is 6. So 6.58, and because we are moving 3 places to the right this time, so 10 raised to power, the power has to be negative. So 3 places, so negative 3. Correct to two significant figures. My first significant figure is this 6, second significant figure is this 5. So I need to look at the third significant figure, which is this last digit 8. This is 5 or greater than 5. I need to add 1 to the previous digit. This becomes 0.0066. 5 becomes 6. This would be the final answer. This is only two significant figures. Next, in the spaces provided, write each number in this calculation correct to one significant figure. So the first one significant figure. Second significant figure is what I look at. This is 7. So I add 1 to the previous digit. So 2 becomes 3. So this becomes 0.003. Next, this is 4, the second significant figure. So previous number remains as is because this is less than 5. Every number before decimal would be replaced by 0. So 3000. Now we have 8 over here. This is the second significant figure. So previous number increases by 1. 9 becomes 10. And the 0 is not significant because this is before decimal and at the end, so this won't be significant. So 10 is just one significant figure. Over here, this second significant figure is 4, so previous number remains as is, and every number before decimal has to be replaced by 0. This becomes 20. Now in the next part, they're actually saying just solve this entire thing. So we can write 0.003 multiplied by 3000 divided by, this is 10 plus 20, so this is 30, and 30 squared, basically this means 30 times 30. So let's cancel out zeros. 1 0 cancelled out from this. The next 0 can, let's say be cancelled out in these two. Now we have 30 over there. Now we can cancel out this 3, this becomes 1, and now 30 becomes 10. Now when I say this is multiplied by 10, the decimal basically moves one place to the right. So this becomes 0.03. 10 is gone because I multiplied this by 10, and this is divided by 3. Now next, I'll multiply the numerator by, I'll multiply the numerator over here, one second. I'll multiply my numerator, give me a second, by 100, and I'll have to multiply my denominator by 100 as well. So that the pen is not working. Okay, multiplied by 100, and this has to be multiplied by 100 as well. So this decimal one place, two places to the right, this becomes 3 divided by 300. So next up, I can cancel these out if in case calculator is not allowed. Actually, for this paper, calculator was allowed, so you could have directly put this in your calculator. In case calculator is not allowed, so both are in the table of 3. So 1 divided by 100. So this is would basically be 1.0. So we just move decimal two places to the left. So eventually you'll get 0.01. I actually solved it without a calculator, but in case calculator is allowed, you can just directly put this in your calculator. This okay. I'll just do this one. Previous question was from a different chapter. Area of small country is this much. Write this correct to one significant figure. Second significant figure is 8. So previous number increases by 1. So 8, and then we replace every next digit by 0, which is before the decimal, of course. So this would be the answer. Write this in standard form. My decimal has to be brought right after 8 over here. So this would basically be 0.0 like this. So 1 place, 2, 3, 4. 4 places to the left. So 8.0. When we are moving to the left, the 10 will have a positive power, positive 4. Okay, previous question was not from this chapter. X are integers. So list the members of x. So we are looking for integers. So for example, this -1, this is an integer, positive or negative whole numbers, and square root of 36 would be 6. So this would be an integer as well. Now next, list the values of y. Y are irrational numbers. So let's have a look at irrational numbers. This is square root of non-square numbers. So irrational numbers are only pi, square root of non-square numbers, or decimals which are non-terminating and have no repeating pattern. So square root of 2 over here, and square root of 30 as well. That is also square root of a non-square number. So these two would be the answer. Next question. This is the last question of this chapter. So here we have a square. The square number is 121. They are saying just fill this up, fill this table. So for a square number, if I take its square root 121, its square root, that would give me its regular number. So if I take square root of 121, calculator is allowed for this one. This gives me 11. So I'll write 11 over here. Now the cube number of 11. To find this, I just need to take 11 times 11 times 11, basically 11 cubed. So this would become 1331. Next, we have a cube number over here. So if I take cube root of a cube number 2744, this will give me the regular number. So a cube root of 2744 would actually end up giving me 14. So this is the regular number 14. Now to find this, I just need to take its square. 14 squared. This would be 196. So I'll write 196 over here. Now this is 343. So if I take cube root of 343, which is a cube number, that will give me its regular number. This would be 7. 7 cubed is basically 343. So the regular number is 7. Now to find its square, I just need to do 7 squared, which is 49, and I need to write 49 over here. Okay, so this is it. This was the last question of numbers and accuracy. Now I'll see you next time with the next chapter. Take care, guys.